Let's talk about equations for a minute. First of all, an equation is a statement that two expressions are equal. And to solve an equation means to find all the numbers that will satisfy the equation, that will make it true. The solution or root of an equation is said to satisfy the equation. And the solution set is the list of all solutions. So a linear equation looks like this. It's an equation that can be written in the form ax plus b equals 0, where a is not equal to 0. This should look familiar. We've seen this equation before. To solve a linear equation, there's a few ways we can do it. We can do it the analytic method, which is paper and pencil, and we can do it graphically. And that often will help us to support our analytic method. You will need to show your work with paper and pencil, but you are free to back it up with tables and graphs. We use several properties to solve equations analytically. First, we have the addition and multiplication properties. And it says that for real numbers, a, b, and c, if a equals b, then a plus c equals b plus c is also true. They're equivalent statements. And the same is true for multiplication. For a c that's not equal to 0, if a equals b, then ac equals bc, and those are equivalent statements, which means they're both true. Okay, here's a problem to try. See how well you remember your algebra rules. Find what x is, pause the recording while you do this, and then resume the recording to check your answer. All right, here we go. We're going to distribute the 3 to the 2x minus 4. Notice on the right side, we're distributing the minus into the x plus 5. That's going to change the sign on the x and on the 5. The next thing we do on the left is we combine like terms. 10 minus 12 is negative 2. And on the right, 17 minus 5 is 12. Next, we add 2 to both sides to get 7x by itself. And then finally, we divide by 7 and get 2 for our answer. It's always a good idea to check your work. So here we put 2 back in for x, and we find out that in the end, both sides are indeed equal. Here's another equation. This one has a fraction. I'm going to let you try this. Pause the recording to do it, but before you do that, let me just give you a hint. These are easiest to work when you don't have denominators. So if you can figure out what the least common denominator is and multiply everything by that, you're going to have a much easier time solving this equation. Okay, here's our answer. The least common denominator for 6 and 2 would be 6. So we're multiplying everything by 6, both sides. We distribute it on the left. When we multiply the 6 times the x plus 7 over 6, the 6's cancel and just leave us with x plus 7. When we multiply the 6 times 2x minus 8 over 2, the 2 goes into 6 3 times, and we have 3 times 2x minus 8. We have negative 4 on the right side because whatever we do, we have negative 24 on the right side because whatever we do to the left, we must do to the right. And then we're going to distribute the 3 into the 2x minus 8 and have x plus 7 plus 6x minus 24 equals negative 24. Combine like terms, so we get 7x minus 17 equals negative 24. Add 17 to both sides. Now we have that 7x equals negative 7. And finally divide by 7 and get that x equals negative 1. Graphically, when we have two linear expressions that are equal to each other, we have 3 possibilities. There could be one solution, and that means that the lines intersect at exactly one point. We could have no solution, in which case the 2 lines are parallel, or we could have infinitely many solutions, in which case both expressions actually represent the same line, so they're on top of each other. All of the points on one line coincide with all of the points on the other. When solving these graphically, we have 2 approaches. The first is to take each side of the equation and set one equal to y1 and the other equal to y2, and then graph. Make sure that your window is a good window that will display the intersection point of the 2 lines. Once you have this, you're going to hit the second and trace button, which will bring up the calc menu. Select intersect, move the cursor until it is as close as you can get to that intersection, right on top of it if you can, then hit enter 3 times. You will notice that the answer is displayed at the bottom. As you can see on the left, x equals 2 and y equals 10. You can also use your table as you see on the right. The x value of 2 gives you the same value for y in both y1 and y2. That means this is an intersection point. The disadvantage to the table is that if you do not have it set up right, you may not actually be able to see the intersection. For example, if x was a decimal, the particular setup of this table would not allow you to see that. Okay, the intersection of graphs method of graphical solution. This just explains what we just did. You take the f of x and g of x, you set one to be y1, the other to be y2. The x coordinate is the solution. Now that's key. You need to give the x coordinate because the question is, what is x that makes this true? Here's a little application problem. During the 1990s, compact discs were a new technology that replaced cassette tapes. The percent share of music sales in dollars that compact discs held from 1987 to 1998 can be modeled by this equation. During the same time period, the percent share of music sales that cassette tapes held can be modeled by negative 4.71x plus 64.7. Now you can see that this is actually going down. It has a negative number in front of the x, so the slope is going down. In these formulas, x equals 0 corresponds to 1987, x1 to 1988, and so on. Use the intersection of graphs method to estimate the year when the sales of CDs equaled the sales of cassettes. Pause the recording, give this a try on your calculator, then resume the recording to check your answer. Here's our solution. We set f of x equal to g of x. We set one equation equal to y1, the other equal to y2. We make sure that we can see the intersection. In fact, if you'll notice the window, we don't even have negative x or y values because they would not make sense in this particular problem. And then we go to the calc menu and we select intersect, and we find that when x is 4.8022599, y is 42.081356. The answer is going to be our x value. Now there's a second approach when you want to graph towards solving a linear equation. And what we do here is we take f of x is equal to g of x. We're going to subtract one entire expression from one side, so we have f of x minus g of x equals 0. And when we do this, what we're going to be looking for instead of the meeting point of the two graphs is where the expression on the left connects with the x-axis. Okay, here's the formal way of putting it. To solve the equation f of x equals g of x graphically, solve y equals f of x minus g of x, which equals capital F of x. So our new equation, once we subtract the two, is going to be called capital F of x. The x-intercept of that graph is the solution to the equation. And notice below it says that root, solution, and 0 refer to the same basic concepts. All of these refer to the same thing. The real solutions of f of x equals 0 corresponds to the x-intercept. All of these are the same thing and tied together. All right, here's an example of how to use the x-intercept method. We're going to solve the equation 6x minus 4 times 3 minus 2x equals 5 times the quantity x minus 4 minus 10. Notice what they did was they subtracted the entire right side and they put it in parentheses. That's really important. You can leave it this way and put it this way into your calculator, or you can simplify it and combine like terms. But honestly, if you're going to be graphing and not doing anything else, if your instructions just say to solve it by graphing, this is probably a better way to go because you have less of a chance of making a minor mistake and throwing your solution off. So putting that entire expression into y1, we're going to find where it connects with the x-axis. Again, go to your calc menu, this time choose 0. When you choose 0, the instructions will be slightly different. You're going to need to find where it crosses, then hit the left arrow key 2 to 3 times and hit enter. Then hit the right arrow key, go beyond where the line crosses the x-axis 2 to 3 times and hit enter, and then go back to where the line crosses the x-axis and hit enter again. Here we find that x equals -2, and again, the x value is our solution. You can also see it in the table. However, if your solution happened to be a decimal and your table was not set up to have decimals, this might not be such a great way to go. You'd want to stick with the graph. Okay, identities and contradictions. A contradiction is an equation that has no solution. For example, x equals x plus 3. If you graph these two things, you get parallel lines. Notice the slopes are the same. The slope for both of these is 1. Parallel lines never intersect, therefore they have no common points. The solution set is called the empty or null set and is denoted or shown by, it's like a 0 with a slash through it. Don't just use 0 because that would indicate that the solution is 0. A 0 with a slash through it is the null set or the empty set. An identity, on the other hand, is an equation that is true for all values in the domain. In other words, no matter what you put in for x, it's always going to be true. This is a case where both lines are actually the same. If you'll notice the left and right side of the equation, if you were to distribute the two, you would get the right side of the equation. These represent the same line. So naturally, all of the points are going to be in common. The solution set is all real numbers, which can be shown by the interval -infinity to infinity. Identities and contradictions, a little bit more on them. Okay, contradictions and identities are not linear, since linear equations must be in the form ax plus b equals 0, where a is not equal to 0. Linear equations have one solution. Contradictions have no solution, they're always false, and identities are always true. So they're not considered to be linear. Now we're going to talk a little bit about inequalities. First of all, some properties. The addition and multiplication of inequalities, pretty much the same as equations with one slight difference. Now addition, no problems. If you have a is less than b, add c to both sides, the expression is still good. A plus c is less than b plus c. We didn't need to change the inequality symbol. Part B says if c is greater than 0, in other words, a positive number, if you take a positive number and multiply it to both sides of an inequality, you're still good. The inequality is fine. If a is less than b, then ac is less than bc. However, the third rule tells us if that number we're multiplying by is negative, then we do have to do something else. If we have a is less than b and we're multiplying by a negative number, then we must flip the inequality sign around. We started with a is less than b, we multiplied c, which is a negative number, and now we have ac is greater than bc. You can try this with numbers on your own and just to prove to yourself that it actually is true and does work. Okay, let's solve this linear inequality. Before you pause the recording, let me remind you, the rules still apply, distributive, associative, commutative. The only difference is that little rule about multiplying both sides by a negative number. If you multiply both sides by a negative, you must flip the inequality around. Pause the recording, give it a try, and resume the recording to check your answer. Okay, here we have it all worked out. First thing we did was distribute, as we would with an equation on the left. That gave us 3x minus 4x minus 8 is less than or equal to 2x plus 1. We then combine like terms. Negative x minus 8 is less than or equal to 2x plus 1. Then they kind of combined two steps here. They subtracted the 2x from both sides. That's why we have a negative 3x on the left. and they added the 8 to both sides, which is why we have a 9 on the right. Then we need to divide both sides by -3 in order to get the final solution, but because it's negative, we flip the inequality around and we get that x is greater than or equal to -3. Notice they also have it written in interval notation, which you should still be using, -3 to infinity, the rectangular bracket next to the -3 because of the greater than or equal to, and the parenthesis next to the infinity. Let's try one with a fraction. Again, let me remind you, these are much easier to solve if you don't have a denominator. Pause the recording, see if you can do it, and then resume the recording to check your answer. Okay, the first thing we did was we multiplied both sides by -3, which made the 2x -6x and the -3 +9. Notice that we also flipped the inequality around because we multiplied both sides by -3. The next step, they added 6x to both sides and got 9 is greater than 7x plus 2. Then they subtracted 2 and got 7 is greater than 7x. And then divide by 7. So we have that 1 is greater than x. Now that's a little awkward. We usually like to have our x on the left. So what they did is they just completely reversed it and flipped the whole thing around. And you have x is less than 1. The solution set would be the numbers from -infinity to 1. Notice that both of those have parentheses. You can also use a graphical approach to solving these. We have the intersection of graphs method. It says, suppose that f and g are linear functions. The solution set of f of x is greater than g of x is the set of all real numbers x such that the graph of f is above the graph of g. In other words, if f of x is greater than g of x, when you graph them, the solutions are going to be all the x's where you see that graph of f above the graph of g. And then the reverse is true. If it's less than, you're going to look for the sets of x's that are below. We'll show you how this works. Here's an example. We have 3x minus 2 times 2x plus 4 is less than or equal to 2x plus 1. Now notice our two graphs here. We have the 2x plus 1, and that's the one that is the positive slope and is rising from left to right. And then the other side is the negative slope, and it is going down from left to right. The equation is looking for where the y1 graph is less than the y2 graph, where it's below it. Well, you notice that initially the graph of y1, the graph of the left, is higher than the graph of 2x plus 1 until you get to x equals -3. And that's where they switch positions, and the right-handed expression is above the left-handed. So we're looking again for where that right hand is above, where the y2 is greater, and that's where it is. So our answer is going to be from -3 to infinity. Okay, when we solve graphically like this, we may have to do some rounding, and when you round, it may actually mean that the symbols we use, whether they be a parenthesis or a bracket, is no longer appropriate because we rounded instead of using an exact number. Because of this, and to avoid confusion, there's an agreement that will be used in this course, and that's what's in the blue box. It says that when an approximation is used for an endpoint, like we have to do sometimes with graphing, in specifying an interval, we will continue to use parentheses in specifying inequalities involving greater than or less than, and square brackets specifying inequalities involving less than or equal to or greater than or equal to. What this is saying is that use whatever the inequality symbol dictates, even if you have to round. So even though you had to round the number because it had a greater than or equal to or a less than or equal to, go ahead and use a bracket there. Okay, we also have an x-Intercept method for the inequality, and it's very similar to the one we used for inequalities. What we're going to do is we're going to subtract the equation, so we have all of the equation on the left side and a 0 on the right. And Once you've done that, if it's f of x is greater than 0, then the answer is all of the x's where the y values fall above the x-axis. And if it's less than, then your answer is going to be all the x's that have y values that fall below the x-axis. This one might be a little bit easier to interpret than the previous method. Example, we have y1 is going to be negative 2 times 3x plus 1, y2 is 4 times x plus 2. What we're going to do is we're going to use the subtraction method, and you see that if you read on down. We took the y1 and we subtracted the y2, and again, you don't have to go through, especially if all you're going to do is graph these. I would probably not try to simplify them, and I would just put them in the calculator this way. It's just going to help you avoid a careless mistake. But this whole thing is supposed to be less than 0. Our y values need to be less than 0, but we need to tell the x values where that happens. So what we're going to do is we're going to find 0 using the 0 function on our calc menu, which we did here on the graph. You can see that the 0 is when x equals negative 1. Now, values to the left of that give us a graph above the x-axis. Values of x to the right of that give us values below the x-axis, give us y values below the x-axis. And that's what we're looking for. We're looking for less than 0. So our solution set is going to start at negative 1 and going to go to infinity. Now we're going to solve a three-part inequality. These are not really much more difficult than a regular equation or regular inequality. It's just that we have 3 parts to deal with. So the first thing we're going to do is we're going to subtract 5 from all 3 parts, the beginning, the middle, and the end. Remember, our goal is to get x by itself. In this case, it's going to be in the middle, and it should be with these. Now we're going to divide everything by 3, and we get negative 7/3 is less than x, which is less than 5, and that's our solution, negative 7/3 to 5. Graphically, we're going to graph the 3 parts, and let me show you what that looks like. You can see here, I've got the different lines pointed out to you. We have the negative 2 on the bottom, we have the 20 going across the top, and the diagonal line is 5 plus 3x. Now the idea here is that x needs to be in between. So we're going to look for the x values that are in between those 2 parallel lines. So in the first graph on the left, you see that the intersection of negative 2 and 5 plus 3x is that x equals negative 2.33, or negative 2 1/3, which, by the way, is negative 7/3. And then on the right, we're finding the intersection of 5 plus 3x with y equals 20. And if you look at the bottom of the screen on the right, you see that the intersection does indeed occur at x equals 5. Some problems to try. Pause the recording, give them a try, resume the recording to check your answer. Do that to the end of the slideshow.